Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels, yeah. Shaky with my passion, took a leap, it got me stable, yeah. Now I make 100K or better, paper couldn't fit a stapler, and I spend it on my passion cause I'm capable. Technically speaking, now I'm really talking vegan when I said that I've been eating, I've been technically speaking. Technically speaking, China white. When I've been said I've been technically speaking, said I've been technically speaking, China white.
So welcome back to another lesson with the CCNA exam prep course here. We are going through each topic of the CCNA exam topics so we can go ahead and take this CCNA exam and work towards our goal, right? Our goal is to get into tech. Our goal is to get 6 figures in the tech. And what all I can do is teach you my footsteps, teach you how I was able to make a little under $250,000 a year in tech. And it all started with this beautiful exam, the CCNA. All right. It was very, very tough for me to study this, but I did pass it on the first go. So what I want to do is give my tips and tricks on how I was able to study this, how I was able to pass this to advance to my goal. So let's get started, you guys. We are still in network fundamentals, section 1, right? It is 20% of the exam. So we want to pay extra attention to this and make sure that we understand these fundamental concepts. All right. Moving on, we have today we're talking about describe wireless principles. Okay. Just like I'm always going to say in every video, please make sure you are taking handwritten notes. Okay. I believe that was one of my strong suits, one of my little tricks. I was able to retain all this information in my head, not knowing any of it, any tech whatsoever, was taking a piece of paper, okay, and a pencil or a pen and writing down these notes, writing down these keywords that I've never heard before, writing down the things that click together. That's like, oh, aha moment, let me write that down. Okay, writing notes, please, 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 please make sure you are taking handwritten notes and not digital notes. Okay, so we are going to talk about describe wireless principles, and we will also dibble and dab in a little bit of virtualization. We're just talking about it, okay? Back to these exams, we're describing and we're explaining. So no need to get too crazy with configuring and trying to be very technical. All you want to do is be able to describe wireless principles and explain virtualization fundamentals. All right? Okay, let's get into it. So let me roll up here. 1.11, describe wireless principles. Specifically, they want us to talk about non-overlapping Wi-Fi channels, SSID, RF, and encryption. So let's go ahead and break each one of these concepts down. Non-overlapping Wi-Fi channels. Wi-Fi channels are like lanes on a highway, you can say, right? They're like pathways through, which wireless signals can travel through, right? So we have something called 2.5 gigahertz frequency range. And these are like 11 channels that are available for Wi-Fi networks. And these networks, these 11 channels, however, overlap each other, as you can see in this diagram. They overlap each other. So it can cause interference and it can degrade performance. So we must choose non-overlapping channels, okay? Which in this diagram, it shows we have 1, which is a non-overlapping channel, 6, which is a non-overlapping channel, and 11, which is a non-overlapping channel. These are what we call 5G channels or 5 gigahertz channels, okay? Now, just going back a little bit, wireless technology, it sends data using ranges of radio frequency rather than a physical cable, okay? And when we say frequencies, a range of frequencies is what we call a band, okay? So you may hear Wi-Fi band, okay? This band is a whole bunch of frequencies put together, all right? So a radio signal, right? The frequencies is like a wave. It goes up and down. Let me go ahead and show you let me see, maybe I can get a picture here, possibly. Oh, here we go. Yes, boom. Okay, so it's like a wave, right? It goes up and down, right? These radio signals go up and down. Now, the height of this wave is called amplitude, okay? And the width of this wave is called wavelength, right? And we measure the wave from peak to peak, right? Each wave, you see, this starts with the wave, it goes down, and then that's a whole wave, okay? And then we do a whole nother wave, all right? These are how we are measuring these waves. And when you think of like data being sent through these waves, or think about like a Wi-Fi signal, think of it like light. You can't see it, because, you really can't see it, that's what it is. But it's like, for example, let me give you an example to better explain it. It's like a dog whistle, right? A dog whistle, you can't hear it, but your dog can, right? So the Wi-Fi signal, the Wi-Fi wavelength, these frequencies, you can't see them, but your Wi-Fi, your router, and your access point, your AP, can actually see it and switch traffic through it. Okay, so these like I said, these frequencies, which is the number of waves that pass through these frequencies, we measure them in a measurement called hertz, Hertz, right? Hertz, like the car company. And then we break it down, we shorten it. Let me go to here. We shorten it by Hz, okay? And then we have a higher I would say a higher measurement in hertz is gigahertz. Remember how we talk about gigabits? So you see how these are kind of all the same thing, all the same measurement, all the same way we are using, that we're measuring this data, okay? Gigabits, gigahertz, it's all just, again, just measurement. And it's good to understand the difference between hertz, whether it's in the 2.4 gigahertz or 5 gigahertz, right? If you want to really get down in the nitty gritty of the hertz and how frequencies are calculated, and using the NyQuil theorem, which is a scientific method of frequencies and how we use them, there is a standard by those internet smarties, the IEEE. That standard is 802.11. 802.11 is what we call it. But for your notes, 802.11 standards. Okay, these are the Wi-Fi standards. And that actually may be on the CCNA exam, if not the Net Plus as well. What is the government standard, not government, but the world standard of governing Wi-Fi signals, Wi-Fi technology? It is the IEEE 802.11 standard. Make sure you write that down. Okay. So non-overlapping channels, like I said, is 1, 6, and 11. Okay. There are 11 channels that we can get Wi-Fi, we can transmit Wi-Fi signal through, but these channels can be overlapped. These channels can overlap each other. If a car is driving and another car is driving in the opposite direction and they're going on the same lane, what are they going to do? They're going to run into each other. It's the same thing with all these 11 channels. Okay. Now, we as engineers, and you can be specifically as a Wi-Fi engineer, a wireless engineer, sometimes just a regular network engineer, you need to understand what Wi-Fi channels are non-overlapping channels to provide the best signal to our end users, okay? And those are 5 gigahertz band channels. Those channels are 1, 6, and 11, all right? You really need to remember that's going to be an exam for sure. 1, 6, and 11 are non-overlapping channels that operate on 5 gigahertz bands. Okay. All right. Great. We got that. Let's move over to SSID. What is SSID? It stands for Service Set Identifier. It's basically just the name of your Wi-Fi network. That's all it is, a fancy word. If you are in charge of your Wi-Fi, or maybe you have access to your Wi-Fi, your home Wi-Fi right now, you can go look on your Wi-Fi box or on the little app, the app in your phone that you manage your Wi-Fi with, or logging into the website that you manage your Wi-Fi with, and you'll see that it has Wi-Fi information, starts with SSID. Well, it probably won't start with, but it'll definitely include an SSID. And then that SSID will be either a default name that your internet service provider gave you, or a name that you chose, like My Wi-Fi or Apartment 123 Wi-Fi, which you shouldn't really do that. But it is just the name of your network. So when you decide to, let's say, go to Starbucks and connect to their Wi-Fi, you will go into your network settings, or you'll probably click your little Wi-Fi little box here, and you will pull it up, and you will see that there's a list of Wi-Fi names, aka a list of SSIDs, service set identifiers. And you can click one. It'll say Starbucks at 123 Main Street. Click on that, right? And then you'll have to put in the password if they have one, and go in. Now, a lot of times they do not, a Wi-Fi network will not blast out this SSID. Sometimes you have to kind of it'll be like a mask identifier. And that's sometimes for security. Sometimes they do that for security. But the point is, what is an SSID? It's nothing but your Wi-Fi name. What does it stand for? Service Set Identifier, as you can see. Okay. Will it be blasted? Sometimes, maybe not. For low security, it will. For higher security, it probably won't be broadcasted out to know what the SSID is. You'll probably have to put it in manually and connect to it. Most of the time, that's not how that is, because it's extra layer of security on this AP. We talked about an AP. What is an AP? An access point. It's for you to it's a device where your computer or your phone or whatever you're trying to can access the network through wireless communication, as you can see in this diagram. This AP has a name. It has an identifier called an SSID. Okay? That's it. Pretty simple. Not going to go too far, because we have a whole lesson on wireless and how to configure wireless for our network, which will be really fun. We'll be able to actually take an AP virtually, though. Well, it's a simulation, and configure that, turn it on, use create an SSID, create a BSSID, and do all what we need to do. So moving on, because we already know SSID. Let's talk about radio frequencies. Let me see if I can, okay, there we go. Radio frequencies, okay, or RF. When you see RF, it stands for radio frequencies. So when we're talking about wireless communication, RF refers to like electromagnetic signals that, used to transmit the data that we're sending, or chats, or going to TikTok, going to Facebook. We are able to access that data wirelessly. We don't have to connect anything in a wire, in an Ethernet cable. Think of it, we know Wi-Fi is a name. Think of it as Bluetooth. Think of it as your cell phone. Think of it like satellite communication, when they're doing like Google Satellite or satellite period communication. They all rely on RF, or radio frequencies, to send and receive information. Okay, so radio frequencies, as you can see, they're like signals that like propagate through the space, the air between us, and it could be affected by many factors. Okay, so it could be distance, right? The signal can get weaker as the distance gets longer. It could be like what we call like obstacles, like maybe a wall, or type of wall, type of material of that wall. If you're in the basement, and you're trying to get signal from the AP that's on the second floor, just so many different types of obstacles, right? Different types of interference. Maybe there's other radio frequencies that's trying to interfere with our frequency. And think of like the weather. Think of like when it's raining, when it's thundering, a tornado, right? A hurricane, or hailing, or just something that is environmental, you can say, can mess up our signals. So Wi-Fi is great. We love Wi-Fi, but it is not as tried and true as a hardwired connection. Okay. So if you ever are running into a situation to where your data slow, maybe your Wi-Fi is slow on your computer or something in that sort, maybe you should do a troubleshooting step by actually taking an Ethernet cable or hardwired cable and connect it to your device and see if that improves your internet transmission. And if it does, then you know that it's something going on with your Wi-Fi. Or is your Wi-Fi box not close enough? Is you're not getting enough signal? Is it some type of interference? And you can just go down the rabbit hole right there of um of troubleshooting, for lack of better words. And this diagram really is just showing you on the spectrum, on the frequency spectrum, where radio frequencies, wireless communication to be exact, is placed. And as you can see here, we have the sound, right? Frequencies and sound. We have AM radio frequencies. We have frequencies that go all the way up to X-rays, ultraviolet light, visible light, right? I don't know if you guys know this. If not, and if it interests you, you might want to deep dive into it by doing a little YouTubing or Google searching. But frequencies, it comes on a wide spectrum, and you can see some frequencies which we will call light, right? And some frequencies you cannot see, like Wi-Fi signal or radio signal or sound, right? But it is still a frequency. It's still a band of waves going up and down, whether you see them or not, right? One thing I loved when I first learned about frequencies, or about how our eyes see things, and what our eyes can see, was like movies. I don't know if you guys know this, but movies, like a motion picture, is nothing but pictures in motion, right? You may think that you are streaming a movie, and you're seeing it in constant motion, but it's nothing but pictures. Okay. When we see a video, it is not a stream of a video. It is actual pictures put together, flickered so many times per second that our eyes perceive it as an actual video movie, right? Like our eyes see it that way, and our eyes have this type of nerve that sends signal back to our brains to interpret what it is. And our brain is like, oh, that's a movie, right? That's a TV show. But in reality, it's nothing but a whole bunch of pictures, flicker, 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 flicker. For another example, light. When you turn on a light, let's for example think about you go into the bathroom. You turn on the bathroom light, and the light bulb is here for you to do your makeup and wash your face, brush your teeth, all that good stuff. You look at that light, maybe not directly, but you see that light, and seems like it's just on. It's just a
In
stream.
today's fast-paced world of technology, staying ahead of the curve is essential for success. But with the ever-expanding landscape of IT certifications, mastering the right skills can seem like a daunting task. Introducing Tech Exam Mastery, your ultimate solution for conquering IT certification exams with confidence. Whether you're aiming to become a networking guru, a cloud computing expert, or a blockchain innovator, Tech Exam Mastery has you covered. Our meticulously curated notes provide in-depth coverage of key concepts, organized in a clear and concise format, saving you time and effort in your exam preparation. Join the thousands of IT professionals who have unlocked their full potential with Tech Exam Mastery. Accelerate your career growth, expand your skill set, and boost your earning potential. Don't just adapt to change, lead it. Tech Exam Mastery. Comprehensive prep notes for IT professionals. Click the link below to learn more.
Light on. But in reality, that light is flickering, flick, 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 flickering. And our eyes are thinking that it's a stream, but really it's not. It's flickering. We call that FPS. So if you work in the movie type of industry or film industry, kind of know what I'm talking about. So you'll see something like 30 FPS. Oh, or if you're a photographer, you may even get to that. It may say 30 FPS. 30 FPS is 30 flicks per second. So per second is flickering 30 times. And your eyes are not. Your eyes, again, look at it as it's just one long string, but it's flickering 30 times in 1 second. But I just thought that was cool when I was going down this rabbit hole of radio frequencies and how we can see and how we can't see sound, but we can see light, and it's all on the frequency band, right? It's all frequency at the end of the day. So I thought that was pretty interesting. Another diagram here that's being shown is frequency equals 4 cycles a second, right? Which equals 4 hertz. So in 1 second, you see this wavelength up and down, up and down. We measure to say this wavelength is X amount frequencies, right? What's the frequency? It's each cycle, right? And the cycle is the peak. Each peak is a cycle, right? As you can see, we have 1 cycle, 2 cycle, 3 cycle, and 4 cycle. 1, 2, 3, 4 peaks, 4 cycles. 4 cycles per second equals 4 hertz. Now, you don't really have to know this math for the CCNA or Net Plus. I just think it's pretty cool to know frequencies and how they're measured and how it correlates to Wi-Fi. You do have to know what RF stands for, and it stands for radio frequencies. And it's literally, wavelengths that travel through air. That's really all you should know. Maybe they may talk about frequencies in a sense, but it's not going to get too deep on the CCNA. But it's definitely important as you start to become an engineer, a network engineer, a wireless network engineer, or even like myself, a voice and video engineer. They call my title UC Engineering, Unified Communications. And that's basically voice and video put together. So I have to have the knowledge to some degree that if I decide to have, for instance, in a conference room, a boardroom, they want some type of video, like a video, like a camera. And so when they take their conferences or take their meetings, the camera shows them and they can talk and connect to it wirelessly. So I have to make sure that the video camera is set up in a proper type of way in the room so the frequencies can actually gather everyone's voice. The frequencies can gather everyone's face and show in the picture of the video, and so forth and so forth. Don't have to do too much of the math. Usually architects are the ones to go out and buy the type of devices and kind of says, hey, make sure you put the camera in the middle of the room. Sometimes it goes down to the senior level engineers that do that as well. I'm not a senior, I'm just regular on the team. So most of the time I take direction from my manager. We don't really have seniors on the team. We're just all the same. And then we have our manager, then we have our architect. So you can say the manager is the senior. And yeah, usually they just tell us what to do with it. And we need to have the understanding of, oh, of course, they want it in the middle for ambiance reasons and blah, 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 right? So moving on to encryption. What is encryption? Encryption is exactly what it is. It's just the process of encoding data to prevent unauthorized access. Okay. So, for example, when you want to connect to a Wi-Fi network, you have the SSID. Oh, it says my network or Starbucks network. We connect to Starbucks or connect to our network, and then what do we have to do? Put in a password, right? That password we're putting in with our keyword, our keyboard. And let's just say that password is 123 Main Street or 1234556. Obviously, we wouldn't want the password to be sent over the network in a plain text type of way. We would want to encrypt it. we'll want to say, okay, that's what you put the password in. It's 1, you're not going to see it on your end. You're going to see dots. So when you put in 1, 2, 3, when you see it on your screen, it'll say a dot, 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 right? And then it's going to be sent over the network and it's going to be encrypted. And then the network takes that encryption to the AP, the access point, the wireless connector, and the AP will take a look at it and be like, okay, this is the encryption. Let me decrypt it. Okay, this is the real password, 1, 2, 3, 4, 5, 6. Let me go ahead. You now have access. I can send your data to our servers or whatever you're trying to do. Okay. Why do we want to encrypt our wireless communication? Because people be hacking. People come in and like to steal your data. Wouldn't you want your password encrypted as it gets sent over the network when you're signing into your bank, right? Let's say you want to check to make sure that your job paid you this Friday. So you have to sign in to Chime, Capital One, Navy Federal, Bank of America. I don't know what you have, but you would sign into your bank's app, put in your password, and the password gets sent to the servers to authenticate that you are the one that's trying to access this, right? So it's encrypted. We wouldn't want somebody to intercept our wireless communication, our radio frequencies, and watch us put in our password, and they just notate that, and then boom, they're able to get in and make transfers and do all this jazz with our network. I don't know, maybe you guys see some movies where the hackers are they're doing a fake phone call to like an elderly lady, or someone like that. Is someone muted? Yeah, maybe. Or like, they come in and they call an old lady or someone who's not technically inclined, and they say, yeah, can you click on this link? And the link literally is like a screen share link or access into their computer. And then they're like, yeah, all you have to do is sign into your account and we just want to make sure that is your identity or whatever type of story they make up for you to sign in. And as you're signing into your account, they're literally able to intercept that and see what buttons you are pressing that make up your password. Okay. And then next, they got into your account. Next, they didn't wipe your account clean. That was actually a movie called The Beekeeper. It came out this year. And it's just like that. It's so crazy how we have all this encryption, all this security, so hackers don't come in and just steal your information. But we have in 2024 where people are not technically inclined, where they're just giving up their information. They're just clicking links. And on top of clicking links, they're just answering the phone thinking that, oh, my bank called me. Your bank will never call you. Don't ever think your bank is going to call you to verify anything. Okay. Or they perpetrate a website and you're like, oh, well, they have the logo, the Bank of America logo, so it must be them. And then next, you just gave the hacker all your information, right? They didn't even have to break into anything. They just called you and acted like a character and you believed it. And I think it's very important that you understand and you learn how encryption works and you learn how to stay safe from hackers alike. So if anything with encryption, please make sure that for you on your personal end, do not click any links. Somebody sends you a link, don't click it. Why? Did you request this link to be sent with you? Did you request a password reset? Did you request more information? I remember one guy, he went ahead and somebody sent him a link saying, oh, you won some type of raffle or some type of trivia or something. I don't know, like a lottery type thing. And he clicked it and it took his whole wallet, his Apple wallet, whatever that was in there, took all that money out of there. All because all he did was click a link that said he won something. And my question was, did you apply to win something? Did you put yourself in a raffle? He's like, no. So why the heck would you click a link saying that you won something if you didn't even apply to be in something, right? So we have to kind of use our critical thinking when it comes to technology, all right? So we'll talk more with Wi-Fi encryptions because we have something that's called WPA, which is a Wi-Fi protected access. We have a version 1, 2, and 3. 3 is the most secure. So when you're looking again, This is good information, even if you're not a network engineer, if you're just a person who handles the Wi-Fi in your home. It's good to understand what type of Wi-Fi encryption you have. Do you have the WAP-A, the P2 or 3? You know, and these protected access, these protocols, they're like algorithms, and they use these, you know, they're algorithms that use security to encrypt the data different type of ways, so they can authorize that as you. All right, so it's just good to understand these principles because they're fundamental at the end of the day, but they're good principles when you're setting up and maintaining a secure wireless network. Right? So when you hear encryption, when you see encryption, literally think about your password. Think about making sure that your data is encrypted as it being sent over the network. And we're talking about Wi-Fi, so your Wi-Fi network to be exact. Okay. That's really it for encryption. Like I said, I don't want to go too far in. So we talked about non-overlapping Wi-Fi channels, right? Non-overlap, there's 3 of them. 1, 6, and 11. Let's go back up so we can show you. 1, 6, and 11. As you can see, these do not overlap. But all of these other Wi-Fi channels, which are 2.4 gigahertz, they overlap, right? So when they say, oh, we got 5G towers, 5G signal, that means that it's fast, it's so fast because these Wi-Fi channels do not overlap each other. Okay, that's all it is. When you think of overlapping, non-overlapping channels, Wi-Fi channels, think of 5G. And then they're gonna, on the test, they're gonna ask you which channels are non-overlapping. There's only 3 of them, 1, 6, 11. Okay. Let's see, SSID, which is literally just your network name, nothing else. Your AP, access point, will advertise the network name in that signal area, and you can go ahead and get on. Wi-Fi name can be defaulted, or it can be what you set it up. It can be set up My Network or Starbucks or whatever you set it up as. I don't know. Radio frequencies it's a frequency, like a Wi-Fi frequency that sends data over radio waves instead of physical cables. Okay, and it can have interference with environmental factors, something such as, is it in this range? There's a lot of reasons why your Wi-Fi or frequency is interrupted, why you're not getting a great Wi-Fi strength or signal, right? And then encryption is what we just talked about, encrypting your data over the network so no one can just find your password, right? We'll talk a little bit more about security and how you can just intercept the network and start reading people's data. We will definitely get into that in section 2. So you can know how to protect the network by hackers are trying to hack into the network. But the first and foremost is encryption. Why do we need that? So our data is not, our plain passwords is not just sent for anybody to see. Okay. And then that was it, right, for 1.11. Now, I did want to talk about 1.12, since, 1.11 is pretty simple, is explain virtualization, okay? So let's go in and talk about virtualization. Now, what is virtualization? What is a virtual machine? Virtualization is basically taking something physical and making it virtual, making it non-physical. For example, we have a computer. We can virtualize a computer. So we can take your laptop, or for my laptop, or just a regular desktop computer, and we can, from that one computer, we can create 50 computers. How do we do so? We do so with a specialized software called hypervisor. Okay. Before we get into hypervisor, I want to pull out this diagram, right? This little picture right here. Let me see. Can I blow it up? Blow it down a little bit. Okay. So we have our regular computer, right? Our computer is hardware. It's a physical computer. Now, on this physical computer, we have software. The software is what we would call OS, operating system. That's where we get Windows, Mac, Linux. These are operating systems, okay? So we just have our, what we call a bare metals. We have our physical computer. That computer has the OS. That OS has applications. Applications such as Zoom, Trello, Chrome, Discord, these are Notion. These are applications that we use on our operating system. Our operating system is used by a physical computer. All right, now we got the architecture of regular computer architecture. Now we want to virtualize that. We want to take that same architecture and make it times 100. How do we do that? We have our one computer and our one operating system, okay? And that operating system would have something called a hypervisor, okay? This hypervisor is what's called a virtualization layer. And this layer says, oh, let's duplicate this OS 50 times. So now 50 times we have 50 Windows computers with 50 instances of Zoom, Trello, Discord, Chrome. Okay, as you can see up here. So our hypervisor virtualization layer, and then from there, we can just what we call spin up a whole bunch of mini computers, mini machines, virtual, because it's not hardware. It's nothing but software virtualized, right? So it's making something physical. It's taking something that's physical and virtualizing it, making it, non-physical. So as we go down some more with hypervisors, there are two types of hypervisors. There is a type 1 called bare metals or native, and then we have a type 2 called hosted. So let's talk about type 1. Type 1 is the hardware, and on the hardware itself, it has the hypervisor software already embedded into the hardware. So now all you have to do is spin up virtual machines, as many as the hardware allows you to, okay? As much memory as the hardware has, or RAM, right? Or you could do type 2, which is hosted. So hosted means that the hypervisor is on your host software. Your host software, you are the host, so it's your software. So just kind of how we are right now. We have a Windows, most of us at least, have a Windows computer. That's our hosted OS. So on that Windows that we have on our computer, we can download a software, VMware, right? Oracle or Microsoft Hyper-V. We can download this software to our computer, which will be a hypervisor software. So we can now, what we call, spin up virtual machines. I know last class, I think it was like a couple years ago in our boot camp, we actually downloaded Oracle and VMware, and we were able to create so many different virtual machines. I was thinking about doing it with this class, but there's so many of you guys that are very brand new to tech that I don't want to pile too much on. So we'll probably do that later on when we finish this kind of exam topics and you guys need more, for instance, more projects or hands-on experience. Because if you are on the realm of being a network engineer, you don't necessarily need to know how to spin up virtual machines. However, if you're going into cloud or even security or systems engineering, then knowing how to spin up a virtualized server will give you a lot of advantage over those others in the job market. So we'll do that later on because I want to make sure that everyone gets the fundamentals first. And then for you guys who are like, hey, I'm going to be in cloud, I want to be a cloud engineer, let's go ahead and create a whole new lesson about how to actually spin up a virtual machine. Oracle, I know for sure, is free. We don't have to spend no money, like, as far as like $5, $10 for a subscription. You could just download it, spin it up, and add your network and all that good jazz. But for this lesson here, just know that there are two types of virtualization hypervisors, one that is on the actual hardware, and type 2, which is actually on your hosted OS. Type 2 is more common. Type 1, you'll probably see it as you work with like servers and stuff, switches and stuff, and a like data center type ordeal. And we call these VMs, virtual machines. And it just helps us with, utilizing our hardware resources. That's really the whole point of virtualizing it. Could cost a lot of money to buy 50 computers, right? But it costs less money if we buy one computer and virtualize that 49 times, right? So think of VMs also as AWS, right? A lot of companies, well, instead of they buying servers and computers and all these other things, they will just have a subscription with AWS to virtualize a machine, a server or a computer, so they can utilize those resources. Let's just say it's cost $150 a month. That's way cheaper than actually buying a computer that costs $15,000 or $1,500 or whatever. It's obviously going to be more than just a monthly subscription to utilize someone else's computer. Okay. AWS, for example, have a big warehouse, we would call a data center. It's a big, big, big building. And it's nothing but a whole bunch of switches and servers and routers, a whole bunch of networking equipment that they use. And on that equipment will probably be type 1, which hypervisor is on that hardware. And they'll just virtualize thousands of computers. So you, as an end user, you as a company, can utilize a server for $50 a month, right? Maybe next week when I go into the office, I can show you guys our data center. I can make a little video of kind of what the data center looks like. I gotta see how security will utilize that, but I can at least show you the overall architecture of how these devices are in a chassis and how we troubleshoot and all these good things. But let's move on. So virtual machines, we use them sometimes unknowingly, and there are 3 types here. We have IaaS, PaaS, and SaaS. Let's start with IaaS. I stands for infrastructure. A stands for as, A stands for A, and S stands for service. So it's infrastructure as a service, okay? It is a service that's being provided, a virtual service that's being provided. And this service that's being provided is infrastructure. So when you think of infrastructure, think of the servers. I don't have to buy a server, but I can pay monthly subscription to use AWS server or Microsoft server or Google servers, okay, to do whatever I need to do with it. I don't know, maybe you want your own email server. Maybe you want to have your own data server, your data storage server. Maybe you just came out with an app, right, a mobile app, and you need a server to host your data of that mobile app or your code of that mobile app. You would probably utilize infrastructure as a service. Now, next one is PaaS. That stands for platform as a service. So maybe you are a developer who is developing that application, right? You might want to use something like Docker as a service or as a virtualized service. So you can build these applications not locally on your computer because it's going to take up so much memory, so much data. And then your computer may crash, may go slow, or you won't be able to download new stuff to your computer because you're trying to build something, you're trying to use your own resources. Use someone else's resources to build a platform, right? Which in this, they give you the servers, they give you the hardware, virtualized, and they give you the operating system. So they give you, like I said, the server, switch, router, whatever, And you also get the Windows or Linux or Mac OS. You get an operating system. So you don't have to use your own operating system, right? And then lastly, which mostly everyone uses, is software as a service. You know, you may hear nowadays with technology being so prevalent, you may hear SaaS companies, SaaS. Everyone's using SaaS technology, SaaS company this. Build a SaaS company. You're going to get money. You're going to make money. That's nothing but software as a service. That's taking a software and licensing out so other people can use it. An example would be Gmail, right? No one holds their emails on their local computer, and no one actually spins up their own virtual machine to host their emails, right? We have we just log in with our password and email to Gmail, Outlook, I don't know, whoever your email provider is. And it's a nice storage, a nice little container for you to host all your stuff, you know, all your emails that come in and go in one location. And that's, again, that's not your server. That's not your computer that your emails are being hosted on. Someone else's computer. For example, for Gmail, it's Google's computer. Okay, Google has an email server and it holds all of your emails, right? Every last blood clot one of them. All right. And you don't, you know what I'm saying? You don't care about that. You're not even thinking about that. You're just like, I'm just gonna log in, or it's automatically on your phone. You don't even log in, you just press the Gmail app and it all pulls up. That's an example of software as a service. iCloud, right? OneDrive. There's so many different software as a service that we don't even realize that we use, but we use them. And if you understand software as a service, that's why people say create a SaaS company, create a software company that you can license out, because hey, that's where the money is at.